So as I've mentioned before, equations of lines have many different forms. We've seen point-slope form, we've seen slope-intercept form. The sort of the last most common form is called standard form. Now, I don't care so much that students are 100% accurate at always looking at the equation and saying, oh, that's in standard form or that's in point-slope form. But it is important for them to understand that there are different strategies for graphing these equations depending on how they look. At the most basic level, we would want students to remember that when you graph an equation, since a graph is all the points that make the equation true, then simply making a table and plugging in x values and determining y values, or vice versa, is always a legitimate thing to do. But again, that depends on your number sensibility, because you're going to run into choices you have to make. Which x value should I plug in that may yield good y values? An equation that's in standard form here has a few things that make it different from other forms of an equation of a line. In point-slope form, we could easily read off a point and a slope. Just by looking at the form. So the point would be 3, 2, that's a point on this line, and the slope of this line is 5. In slope-intercept, we can still get the slope of 1/5. And again, depending on how fluent students are, they may recognize that the y-intercept is 6. But even if they don't, they can get that point by plugging 0 in for x and figuring out that y would be 6 when x is 0. But in any case, they get the slope for free in both of these equations. And we try to get students to understand that, you can't just say, well, the number in front of the x is always the slope, because that really is only true when your x and y coordinates are sort of on opposite sides of the equation, as they are in the first two examples here. So it's inaccurate to say that the slope is 2 in this equation just because we see that there's a 2 next to the x. It turns out that that's not the case. And it turns out that an equation in standard form doesn't really give us anything for free. In other words, we can't just read off information when an equation is in standard form. So I don't know the slope, and I don't know a point on this line just by looking at it. So in this case, we have students sort of go back to basic principles. They make a table, and they pick a number for x. And an intelligent number to pick for x is going to be 0, because it's going to cause the term 2x to go away. So when I plug in 0 for x, you'll see that I get 2 times 0, which is 0. And so we don't even write it at this point. We'll just put down 3y equals 12 when x is 0. And this equation, many students can do mentally. 3 times y equals 12 indicates that y is 4. Now, I know it's common to want to plug in numbers for x, but that doesn't have to be the case. We could plug in numbers for y as well. And the symmetry of the left-hand side here suggests that maybe we could plug in 0 for y. And if we do that, you see that the term 3 times y goes away, because it becomes 3 times 0. And we're left with 2x is equal to 12, which indicates that x is 6. So now we have 2 points on this line. Now at this point, as a math educator, you want students to know that 2 points really isn't enough to know for sure that you have a line, because there are many different types of graphs that could be going through these 2 points, 0, 4, and 6, 0, that aren't lines. However, after enough exposure to these equations, we know that students can sort of recognize that this is going to look like a line. I may not know immediately what the details of it, but I know that this looks like a line. This looks like a line, or the form of an equation of a line that I've seen before. So we let them get away with just getting 2 good points, 0, 4, and 6, 0. and plotting those points, 0, 4, and 6, 0. And then using this idea of slope to get more points. So the slope between these 2 points, if I go to the graph, would be down 4, down 4, and right 6, which can be reduced to negative 2 divided by 3. And so by using that slope, they can start at any point, probably the one on the left would be a good choice, move down to right 3, down to right 3, up to left 3 to get more points. And so now we have the line graphed. It was a little more work than what we saw in previous videos. But again, one of the key features we want students to understand is that lines have different representations, and the representation is going to determine how they decide to actually graph the line in the end.